And if there are non-repeated roots on the j omega axis, then the system is limitedly stable. You can see the limitedly stable condition here. If the roots are on the j omega axis, it is limitedly stable. Like here, there is a root at origin that is also on j omega axis. System is limitedly stable, that is neither stable nor unstable. And here also, if you see, the roots are on the j omega axis. The system first condition, that bounded input, bounded output condition is met. But in the absence of input, the output doesn't tend to 0. So that is limitedly stable condition, this and this. Remaining things, if the roots, if there are another condition is there, that on the j omega axis, multiple roots are there at the same spot. You can see double roots, double poles at the same spot here and here on the j omega axis, or at the origin also. If there are multiple roots at origin, that means s square is equal to 0. Then also system becomes unstable, not limitedly stable. Indirectly, if the roots are lying on this side of the j omega axis, then system is unstable, and this side it is unstable. So this is called as S plane, sigma j omega plane. Then to determine the stability, that means you have to find the roots, and finding out the roots is very complex thing. Up to third order root only you can find out by using what is known as by using your normal method of solving the equations. But after third order, it is not possible by using even calculator also. Hence, the method developed is Routh-Hurwitz criteria. The Routh-Hurwitz criteria puts into this form of an array, and this array has to be calculated. You know how to calculate this array. If all the elements in the first column of the Routh's array are positive, then the system is stable. If any one of the elements in the first column of the Routh's array is negative, then the system is unstable. And the number of sign changes in the first column of the Routh's array indicates number of roots on the right side of the S plane. That means which causes the instability. And before starting the Routh's array, you should see that all the terms in the polynomial has to be present and they have to be positive. If any one of the term is missing or any one of the term is 0, it indicates the system is unstable. And at the same time, if any one sign of the Routh's array is negative, then also system is unstable. So we have seen two normal cases where in the first case we have seen in the previous class, we have solved the Routh's array. That is, here you can see, I repeat once again, this is the polynomial given to you. This is the denominator of closed loop transfer function, that is s4 plus 8s cube plus 18s square plus 16s plus 5 is equal to 0. First, you have to see whether all the terms are present or not. Highest power of s, 4 is there, 3 is there, 2 is there, 1 is there, 0 is there. And all the signs between them is positive or not, that you have to see. All are positive, then you can proceed for the Routh's array. Arrange the Routh's array in this fashion. First, highest power of s, that is 4, that is 1. Leave 1, then write next, that is leave s cube, write s square, that is 18. Then leave s and write s to the power 0, that is 5 in the first row. In the second row, remaining parts, that is highest power is s cube, that is 8, then is 16, then 0. You can take common here in the second row because 8 is common, so it will become 1 and 2. It is not mandatory to do this. If you do like that, you can do the calculation very easily because the number size will decrease, and without the calculator also you can do it. Then to calculate the s square term now, this into this, 8 into 18 minus 1 upon 1 into 16. 8 into 18, cross multiply this, 8 into 18, 1 into 16 divided by key element, that is the 8 has to be written from where you have started. So that becomes 16 here. Similarly, 8 into 5, that is 40, minus 0 divided by 8, that is 5 only. 40 divided by 8 is 5. Like that, you will get 16 and 5 in the third row, that is a square row. Next row, you have to calculate 16 into 16 minus 8 into 5. 16 into 16 minus 8 into 5 divided by 16. That is the key element, that is the of the third row. To calculate third row, to calculate fourth row, third row becomes key element. Calculate third row, second row becomes key element. Remember that. So it will become 135. Then there is no other calculation here. Then the last row, 135 into 5 minus 0 divided by 135 is 5 only. So in the first column element, if you see now, 1, 8, 16, 135, 5. All are positive. System is stable. Then in the second problem, it is unstable case. You can see here, it is 3s4 plus 10s cube plus 5s square plus 5s plus 2. This is what is there. So I arrange first s4th row, 3, leave this, next 5, leave this, next 2. In the second row, 10, then leave this, 5. You can take common here, 10 and 5, you can take 5 common, divide the whole row by 5. So it will become 2 and 1. So now you have to multiply 2 into 5, 10 minus 3 into 1, 1 divided by 2. That is 10 minus 3 divided by 2, that is 3.5. Then 2 into 2, 4 minus 0 divided by 2, that is 2. So the next row, if you calculate 3.5 into 1, that is 3.5 minus 2 into 2, 4. That is 3.5 minus 4. That is minus 0.5. Minus 0.5 divided by 3.5 is negative. Then the last row, 2 in this is minus 0.5 into divided by 3.5 into 2 minus 0 divided by the same quantity becomes 2 only. See here, this is positive, this is positive, this is positive, this is positive, this is negative, and this is positive. So that means as one of the elements in the first column of the Routh array has become negative, hence the system is unstable, and the number of roots causing this instability is depends upon the sign changes. Up to here the positive sign is there. From positive to negative, first sign change, and once again from negative to positive, second sign change. So two sign changes are there. Hence the two roots are on the right side of the S-plane, and hence the system becomes unstable. Then we have seen the application, how to find out the value of K. For example, if you see here, this is the equation, and this is the equation for K. This is open loop transfer function is given. This is G of S, means it is open loop transfer function. Then to find out the closed loop transfer function, you have to do 1 plus G of S, H of S is equal to 0. H of S is unity feedback is given. So H of S is 1. So G of S into 1 is G of S only. So that is equated to 0. So add 1 to this. So it will become K. If you add 1 to this, then K into S plus 1 into S plus 2 plus S plus 0.1 S minus 1 that you will get. And that equated to 0 means the denominator goes off. So then arrange in the decreasing order of S. So it will become 1 plus K into S square plus 3K minus 0.9 into S plus 2K minus 0.1 is equal to 0. Now arrange the Routh array. S cube term 1 plus K, leave this, write this. S square term, this one 0. So simplify this into this minus 0 divided by this is this one only. And so from here, S to the power 0 term we have reached. See, 1 plus K should be greater than 0. So that means K should be greater than minus 1. That is the first condition, because this has to be positive. If this has to be positive, that means 3K minus 0.9 should be greater than 0, or K should be greater than 0.3. And the third one is 2K minus 1 should be greater than 0, or K should be greater than 0.05. So that means K should be greater than 0.3, 0.05, minus 1. So 0.3 is the highest number. So K should be greater than 0.3. If K is equal to 0.3, the system is limitedly stable, because one if you put K is equal to 0.3, this term will become 0. You see here. If you K is equal to 0.3, 0.3 into 3 is 0.9, 0.9 minus 0.9, it will be 0. So neither it is positive nor negative, hence it is a limitedly stable. Whereas if the K is less than 0.3, it is unstable. K is greater than 0.3, the system is stable. So similar type of problems we have already discussed in the previous class for finding out the value of K. So this is the main application of Routh stability criteria. You can determine what gain is required for the system to become stable, or what gain has to be there to make the system limitedly stable or unstable as your wish is. Generally, stability analysis means you are interested only in stable system. So what value of K or what gain of the system makes the system stable, that you can use by find out by using Routh stability criteria. Then we have seen special cases. There are two special cases or two difficulties which commonly we encounter. So the first difficulty is when the first column element of the Routh array becomes 0. When the first column elements of the Routh array becomes 0 means that you cannot proceed further, because that first column element has to be used in the next iteration. You have to divide it by that. When you divide it by that, it will become infinity. Then when it becomes infinity, in the next row, it will become 0. Or you are go on getting the terms called as infinity by infinity or 0 by 0 type of arrangement. 0 by 0 or infinity by infinity terms are not defined. So we should avoid that. So this is the first difficulty. Why this difficulty occurs? Basically, that is most important part. Why it occurs? The first column of the Routh array becomes 0 means that there are symmetrically placed roots on by the sides of the j omega axis. Symmetrically placed roots. That means there may be one root at say -1 and one root at +1. That is, one root is on the left hand side of the imaginary axis and one root on the right hand side of the imaginary axis with the same value, +1 or -1. This is one case. Or there may be a case where in addition to that, there may be a complex conjugate set of complex conjugate roots similarly symmetrically placed along both sides of the j omega axis. That is, say -1 plus j, -1 minus j, both are lying on the left hand side. Similarly, you have another set of roots with +1 plus j, +1 minus j. That means there are two roots on the right hand side and two roots on the left hand side, but they are symmetrically placed. So what happens is they are called as quadrates. They are called as quadrates. That means two roots on the left hand side, two roots on the right hand side, but they are at the same distance along y axis also, along x axis also. For example, -1 plus j, -1 minus j. -1 plus j is on the left hand side at a distance of -1 units towards left and +1 units towards upper side. Similarly, -1 on the left side, but minus j, that means -1 on the downside. So that means there are two roots on the left hand side with -1 only. Similarly, there are two roots on the right hand side with +1 only. That means it looks like a square. If you connect all the four roots, it will make a square. But two roots on the right, two roots on the left. The system is unstable only. In such cases, the system will be unstable because there are roots on the right hand side. But that indication you will not get. You will not get sign change there. One of the element becomes 0 there. And 0 means you are always in the doubt. 0 means whether it is positive or negative. We don't know. So in that case, the best method to proceed further is substitute it by a small positive quantity epsilon. So here there is one example regarding that. We'll take this polynomial, that is 1 plus g of s h of s equal to 0. This is a characteristic equation given here. S5 plus S4 plus S cube 2S cube plus 2S square plus 3S plus 5 is equal to 0. Now, as usual, see all the signs are positive, all terms are present. Like 5 is the highest, 4 is there, 3 is there, 2 is there, 1 is there, 0 is there. S to the power, all the terms are present. That means this may be stable. Now arrange the Routh array. S5 term is 1. Leave this right next, that is 2. Leave this right next, that is 3. Here, if you write second row, 1. Leave this 2, then 5. See now what happens? 1 into 2 minus 1 into 2. That is 2 minus 2 is 0 divided by 1. So when 0 is there, if this element is 0, if you calculate next row, what will happen? Just see. 0 into 2 is 0. Then, so here, see here, the another term is there. Here, 1 into 3 minus 1 into 5, that is minus 2 upon 1. That minus 2 term is also there. See, here, only one element is 0. This element is not 0. See, whole row, if it is 0, it is a separate case that we'll discuss later. This is only the first column element has to be 0. So the treatment is different. Only one column, first column element is 0, treatment is different. And once whole row becomes 0, the treatment is different. Remember that. Don't get confused. That we have to do it still. We have to do it. So if you put this as a 0 here, I am substituting as epsilon, but before that, if you put it as equal to 0, 0 into 2, that is 0, minus of minus plus 2 into 1, 2, divided by 0. That means 2 divided by 0 is plus infinity you will get. So this term, if it becomes plus infinity, subsequently infinity multiplied by anything is infinity with a negative sign. 5 into 0, that is 0. Infinity divided by infinity is meaningless. So the Routh's array degenerates. It is called as degeneration of the Routh's array. So to overcome this difficulty, what I will do is, I will put a small positive quantity epsilon here, which is not 0. Which is not 0, but we'll evaluate as epsilon tending to 0. If you put epsilon is here, then you have to proceed as usual. Epsilon into 2 is 2 epsilon. Minus of minus plus 2 divided by epsilon. This is the first term. Second term is epsilon into 5, that is 5 epsilon minus 0 divided by epsilon. So 5 epsilon divided by epsilon is 5. This is the next term. Then next proceed further. This multiplied by minus 2. So 2 epsilon plus 2 divided by epsilon into minus 2 is minus 4 epsilon minus 4 minus 5 epsilon square. If you simplify that, because 5 epsilon comes from this side, so this 5 epsilon is there and the LCM is epsilon, that because of that it will become epsilon square here, that divided by 2 epsilon plus 2, because this epsilon I have taken it in the numerator. Okay, then the next term is this into 5 minus 0 divided by this is 5 only. That means if you see now the first column elements, this is 1 positive, this is 1 positive, this is epsilon which is tending to 0 is positive epsilon only. Then you put in this equation epsilon tending to 0. So if you put epsilon tending to 0, 2 into 0 is 0 plus 2, that is 2 divided by 0 is plus 2 divided by 0 is plus infinity. So it is sign is plus here. But here if you put that, if you put epsilon is equal to 0, this is 0, this is minus 4, this is 0, this is 0, this is 2. So minus 4 divided by 2 is minus 2, correct? And this is already 5. So now you can see this is positive, this is positive, this is positive, this is also positive because it is positive infinity, but this is negative and this is positive. As the first column element in the Routh's array has become negative, hence the system is unstable. And at the same time, you can see one of the first column element has become zero. That means there are symmetrically placed roots. And the third one is there are two sign changes here: positive, 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 negative, positive. Positive to negative first sign change and negative to positive second sign change. So because of that, there are two sign changes. That means there are at least two roots on the right hand side of the S plane, and that is why the system is unstable. Sometimes this method of substituting epsilon always works. It always works. You have to solve the problem of this kind like this only. But sometimes you can do it by another method. This is not a foolproof method. What I will do is I will put S is 1 upon S is equal to Z. If I put 1 upon S is equal to Z in this equation, so this becomes 1 upon Z5, 1 upon Z4, 2 upon Z cube, 2 upon Z square, 3 upon Z plus 5. Correct? And then you take Z5 as LCM. So the polynomial will get reversed. So it becomes 5Z5, 3Z4, 2Z cube, 2Z square, 1Z and plus 1. See this. This is the equation. That means I have changed the coefficients. Z5, S5 coefficient has become S to the power 0, whereas 5 has S to the power 0 was now become 5 as S to the power 5. So I have to identify that it is a different polynomial. Instead of S, I have substituted 1 upon Z, and this polynomial you can solve. Now this is 5Z5 plus 3Z4 plus 2Z cube plus 2Z square plus Z plus 1. Now solve the usual Routh's array. So 5, 2, 1, 3, 2, 1. See here, 5, first row, 5, leave this, 2, leave this, 1. And in the second row, 3, leave this, then leave this, next to 2, leave this, 1. I have arranged the Routh's array like this. Now 3 into 2 is 6 minus 10. That is 4, minus 4 divided by 3. Then 3 into 1 minus 5 divided by 3, that is minus 2 upon 3. So here also you can take common, but minus sign you cannot take common. Remember that. You cannot take minus sign common. So you can take 2 by 3 common. This becomes 2, this becomes 1. Then it becomes simplified. But here it is done as it is. So next row, this into this, that is 8 by 3 with minus sign plus 6 by 3 with plus sign. So it will become divided by minus 4 by 3. Minus upon minus is plus. So here you will get a half. See here the sign is 8 by 3 plus 6 by 3 is minus 2 by 3. But divided by 4 by 3 is there with minus sign. Minus minus sign cancels and half will remain. And then this becomes 1. This into this minus 0 divided by this is 1. Then next row, this into this minus this into this plus divided by this, it will become 2. Then it will become 1. Now you can see the first column of the Routh's array. 5 positive, this is positive, this is negative, this is positive, this is positive, this is positive. There are two sign changes, system becomes unstable. But this method, remember, of substituting S is equal to 1 upon Z, it will not, there is no guarantee that it will give you correct result all the time. It will fail sometimes. Sometimes what happens, it depends on this term also. If this term also and the arrangement of the coefficient depends upon that. So the best method is epsilon method only. Always try to do it the epsilon method. No, don't waste your time in the exam by trying to do it by 1 upon Z method. It is no way helpful. It is never, it is very rarely it is helpful. But you can tackle like that also. That's why it is given. It is same problem from the Nagarapopam. Okay, we'll take a break now. And another two special cases are there in this. We'll come to that at 11 o'clock. Any questions regarding this? Do you have any questions? You can unmute your mic and tell. Regarding the portion for third IA or a makeup IA, actually, because most of you have already might have got the good marks. Second IA papers have to be corrected. So they will the marks you will come to know within 2 to 3 days. So the portion for this IA is what is known as, sorry, I forgot to do the recording part. Anyway, in the next class we'll do it. Now the portion for the IA is, that is time response analysis. That is first order, second order system, time response in all respects along with the problem, and Routh stability criteria. Whatever is the portion covered up to today's class. Today we are going to finish the Routh stability criteria. Root locus, that means it is half unit of unit number 2 and half unit of unit number 3. That is only time response analysis. Only time response analysis. Some portion may be repeated. That is first order system, second order system was already derivations were asked in the second IA test, but that will be once again there with the problems on first order and second order. Second order was not there in the test, no? So only for open book it was there. So first order, second order system along with the problems and the Routh stability criteria along with the theory. As usual, you will get 3 questions and you have to answer any 2. Is it okay? Portion is already in the classroom. Yeah. Yeah.
Okay, sir.
Okay. We'll take a break. We'll meet at 11 o'clock and finish off this topic. combination exists. Here multiple combination exist out of these three combinations which are discussed. So in that case, how to solve that? The next we can take the example. If you take the example here, S6 plus 2 S5 plus 8 S4 plus 12 S cube plus 20 S square plus 16 S plus 16 is equal to 0. Highest power of S is 6 and all the signs are positive, all the terms are present. S to the power 6, S to the power 5, 4 is there, 3 is there, 2 is there, 1 is there and 0 is there. So you can proceed further. Then arrange the Roth array. So this is 1. So I will write 1. Leave this, write next, that is 8. Leave this, write next, that is 20. Leave this, write next, that is 16. So 1, 8, 20, 16 is the first row. Second row, 2, leave this, 12, leave this, 16. So you can write 2, 12, 16. You can take 2 common here. So 1, 6, 8 it will become. 2 divided by 2, 1. 12 divided by 2, 6. 16 divided by 2, 8. So then if you proceed further, 1 into 8 minus 1 into 6, that is 2 divided by 1 is 2. Whereas 1 into 20, that is 20, minus 8 into 1, 20 minus 8 is 12, divided by 1 is 12. So the last one is 1 into 16 minus 1 into 0, that is 16 divided by 1 is 16. So 1, 12, 16. I can take once again common here. 2 common you can take. That means 1, 6, 8. See here, this is also 1, 6, 8. This is also 1, 6, 8. That means naturally these terms will be 0 only. So because these two rows are identical, that indicates the next row will be 0 only. That is 1 into 6 minus 6 divided by 1. That is 0 divided by 1 is 1. Then 1 into 8 minus 8 divided by 1. That is 8 minus 8 is 0. So in this case, what you have to do? You cannot substitute here as epsilon. Remember that. Because you may say that first column element of the Roth array has become 0. Like the previous difficulty 1. You cannot substitute epsilon here. If you substitute epsilon here, in the next row, once again, you will face the same problem. So in that case, what you have to do is, the row preceding the row which has become 0. This is the row which has become 0. That is S cube row has become 0. Row preceding to that is S4th row. See this S4th row, you write what is known as auxiliary equation. See S4th row means the highest power here is S4. Then it is not S cube, it is S square. Then this is S to the power 0. Because alternate elements are going to be written. See here, S6th row means this is S6, this is S4, this is S square, this is S to the power 0. This is not S cube. S cube row, odd rows are below, even rows are at the top. It is not always. This is a starting with even equation. That's why the even in the first row, odd in the second row. If this is an odd equation with the highest power of S is 5, then odd will be the first row, even will be the second row. So S4th row is now the auxiliary equation because S cube row has become 0. S4th row I will write it as it is. That is 1 S4 plus 6 S square plus 8. 1 S4 plus 6 S square plus 8, that is written as A of S. This is called as auxiliary equation. Then you differentiate this. You differentiate the auxiliary equation to go back to the next row. So because now after differentiation, S4th will become S cube. So you can write S cube row. So if you differentiate that S4th, so it will become 4S cube plus 12S plus 0. So 4S cube plus 12S. These are the terms. Substitute back into the array. Substitute back into the array. S cube row, see here, this is 4S square plus 12 is there. You can take 4 common. So it becomes S cube plus 3. S cube plus 3S. S cube plus 3S. If you write S cube plus 3S, S cube row, I will write S cube coefficient is 1 plus 3S, second coefficient is 3. I will write. So you can proceed further now. S square wave. So 1 into 12, or this is, you can write it as 1 into 4 into 12, 4 and 12 is written here, and 4 is taken common. 1 into 3 is there. So 1 into 6 minus 3. 6 minus 3 is 3 divided by 1 is 3. Then 1 into 8 minus 0 divided by 1 is 8. 3 and 8 will be this. Then the next row, 3 into 3 is 9. 8 into 1 is 8. 9 minus 8 is 1. 1 upon 3. And the last row is 1/3 into 8 minus 0 divided by 1/3 is 8. Now see the first column elements of the Routh array. All the first column elements of the Routh array has positive. That doesn't mean the system is stable. Here there is a catch. Why it is not stable is one of the row has already become 0. One of the row has already become 0 means the system may or may not be stable. So you have to proceed further. See the auxiliary equation S4 plus 6 S square plus 8. S4 plus 6 S square plus 8. This is auxiliary equation. It is the highest power is 2. So you can easily find out its roots. So minus b, that is minus 6, plus or minus under root of b square, that is 36 minus 4ac, that is 4 into 8, 32, divided by 2a, that is 2. You will get the roots as plus or minus j omega, plus or minus 2j only. That is because you will get this is minus 3 so you will get only 4 roots, that is 2 roots are that is plus or minus root j, and second one is plus or minus 2, because the roots will be S4th row is there. So it is a quadratic equation with a square term. So S square raised to 2, S square raised to 1, S square raised to 0 term is there. So S square value we will get is minus 3 plus 36 minus 32, that is 4, root 2, it divided by 2 like that. And another one is minus 3 plus 2 divided by 2. So the 2 roots will be like this. So in all there are 4 roots. 2 roots at plus or minus root 2j. 2 roots are plus or minus 2j. So on j omega axis there are 4 roots. 1 root at plus root 2j, 1 root at plus 2j, and 1 root at minus 2j, and 1 root at minus root 2j. So 4 roots are there on the imaginary axis. So totally there are 6 roots, out of which 4 are on the imaginary axis. But there is no sign change. That means remaining 2 roots are on the left hand side. But the 4 roots are on the j omega axis. If there are roots on the j omega axis, but they are non-repeated roots. At the same spot, there are no 2 roots. Hence, the system is neither stable nor unstable, but limitedly stable. Have you understood this? See, it is not unstable, but it is not stable also, because there are roots on the j omega axis. Those roots we have already found out. Remaining 2 roots also you can find out. Remaining 2 roots you can find out by dividing the auxiliary equation to the main equation. That part I have not done. So because there are overall 6 roots are there, these are the 4 roots. So you take the main equation, this is the main equation, divide it by auxiliary equation. So you will get remaining 2 roots. So those 2 roots can be on the, definitely will be on the left hand side with having negative real part. So hence the system is neither stable nor unstable, hence it is limitedly stable. But suppose in this process one of the sign has become negative, then the system is unstable only. But here there is no sign change, that means you cannot write the system is stable, basically because one of the row has become 0. One of the row has become 0, that means it clearly indicates there is a presence of roots on the j omega axis. When there is a presence of roots on the j omega axis, first stability condition is met. That is, if the input is bounded, output is bounded. But the second condition, in the absence of input, output should tend to 0. This condition is not met, and the system will keep on oscillating for infinite amount of time. Hence, the system is limitedly stable. Yeah, yeah. So if the first row is 0, here you have to stop. No, no. So first, when the first row becomes 0, you should not stop there and don't use that epsilon method. So both the terms are 0 means both the terms should be possible there. See what happens sometimes s to the power 1th row, s to the power 1th row. Suppose now s cube is there, after that s square is there, after that s1 is there. If this element becomes 0, then it is not the question of auxiliary equation, right? Because there will be only one term and that term is absent means what happens is that term an, this an is 0 actually. That will happen in the case of an only, and that you know beforehand because that term will be missing. An term, that is s to the power 0th term, will be missing in the equation. That clearly indicates there is a presence of root at the origin only. If there is a root at the origin, then also system is limitedly stable. Then also system is limitedly stable, but there is only one root at origin, and that without solving the Roth's array you will come to know that basically because this term will be 0 in the initial equation only. An term will be 0. So such those can be identified very easily. But suppose this row can be 0, a square row can be 0, s cube row can be 0, or a square row can be 0, or any other row higher than that can be 0. In that case, you have to do by this method. So this is difficulty 2. That is, one of the rows in the Routh's array becomes 0. In that case, what you have to do? Take the preceding row, which has not become 0, write the auxiliary equation, differentiate the auxiliary equation, and proceed further and complete the analysis. This finding out the roots is optional. It is for your sake you can do it because you have to get the further details. Then see the application which you have done already. This is one function given, one transfer function. Open loop transfer function is k divided by s into s square plus 1 plus s plus 1 into s plus 4. So it is 1, 2, 3 plus 1, fourth order equation. And unity feedback is there, negative feedback is there. So you find out the closed loop transfer function. Closed loop function g of s divided by 1 plus g of s h of s. That is this divided by this into 1. So it becomes k into this one. So find out the characteristic equation denominator, that is s into s square plus 1 plus s into s plus 4 plus k is equal to 0. Multiply this and simplify. So it will become s4 plus 5s cube plus 5s square plus 4s plus k is equal to 0. Now the application is for making the system stable, what should be the value of k? This type of problem we have already done. We are doing one more problem like that. So arrange the Roth's array as usual. This is 1, leave next, right next, that is 5, leave next, right next, that is k. Then below that, it is 5, 4. And by mistake, it is printed as 12. It is 12 is not there. So 5 into 5, 25, minus 4, 21 divided by 5. Then 5 into k, 5k minus 0. It is not 12 is not there. Minus 0 divided by 5 is k only. Then you proceed further. 21 divided by 5 into 4. That is 84 divided by 5 minus 5k divided by 21 by 5. And last one is k. So all the elements of the first column should be positive. That means from that first k should be positive. That means k should be greater than 0. This is the first condition. Second condition is this term should be greater than 0. That is 84 by 5 minus 5k divided by, yes.
So we should, after realizing the polynomial, sir, making the characteristic equation, so we should use only the first and second order, highest two orders, sir, to start with Routh array, sir.
No, highest highest, you are talking about auxiliary equation.
Yes, after making the auxiliary equation, so s raised to 4 plus 5s.
Yeah, here this is auxiliary equation. This is
Sir.
auxiliary equation that you have to differentiate.
So this
Differentiate auxiliary equation
characteristic
and
equation,
substitute in S cube row.
the characteristic equation, sir, not auxiliary equation, sir.
Characteristic equation can be of any order.
So it can be any of any order, sir. But how many orders we should consider, sir, to make the Routh array, sir, initially?
No, order is what is the highest power of S is the order of the equation. This is a sixth order equation. Sixth
Yes.
order equation means 6 roots are there.
Yes, sir.
So it may be fourth order, third order, second order. Eighty-four by and k should be greater than 0. That means here you have got two values. You have got the double value. K should be greater than 0, but it cannot be anything. It should be less than 84 by 25. It is approximately less around between 3 point something. It should be below 3 point something, 84 by 25. Otherwise, what will happen? The system will become unstable. So if k is less than 0, then also unstable. If k is greater than 3 point something, then also it is 0, unstable, like that. And at k is equal to 0 or k is equal to 84 by 25, you will get complex conjugate roots on the j omega axis. That is what he has done. You can see here, if you put k is equal to 84 by 25, if you put k is equal to 84 by 25, this term is 0. The next term is already 0. That means it is already a whole row has become 0. Now the row preceding to that is this row, a square row. That is a square 21 by 5 a square plus k is equal to 0. 21 by 5 a square plus k is equal to 0. Value of k is 84 by 25. I have put here. Then if you solve this, s is equal to 4 by 5. S is equal to 4 by 5 j, root of 4 by 5 j. There are two roots on j omega axis, and hence the system becomes limitedly stable. That means if k is equal to 0 and k is equal to 84 by 25, system is limitedly stable. If k is less than 0 or k is greater than 84 by 25, then the system is unstable. But if k is greater than 0 but less than 84 by 25, system is stable. Then another case. See here, this case is given only in the Nagaraj Gopal, no other book you have. And actually it is there in Raven also, but different problem is there. But this case, this problem we are taking specifically reason because 2-3 times this question is asked. Same problem has come in the exam and very typical one. See, this is the polynomial. A sixth polynomial is given. All terms are there. All terms are positive. Now what happens? Just see in this. So this is 1, leave this 3, leave this 3, leave this 1. 1, 3, 3, 1, first row. Second row, 1, leave this 3, leave this 2, leave this 0. So 1, 3, 2 is the second row. Proceed further. 1 into 3 minus 3 is 0. So 1 into 3 minus 2 is 1. 1 into 1 minus 0 is 1. So epsilon 1, 1. Whole row is not 0, but the first element is 0. That is 1 into 3 minus 3. So other two elements are present here. When the other two elements are present means it is the first difficulty, not the second difficulty. Whole row has not become 0. So I have done it by epsilon method. I have substituted it by epsilon. Now calculate further. 3 epsilon minus 1 divided by epsilon. 2 epsilon minus 1 divided by epsilon, 0. This is the third row, S cube row. Then a square row, this into this minus this divided by this. After solving, you will get minus 2 epsilon square plus 4 epsilon minus 1 divided by 3 epsilon minus 1. And this into 1 minus 0 minus epsilon divided by this is 1. Correct? Then I have proceeded further. This whole thing multiplied by this minus this divided by this. After simplification, it will become like this. And the last is 1. Okay. Now see here. Now you have to substitute epsilon tending to 0. If you substitute epsilon tending to 0, this is 0. If you substitute epsilon tending to 0, it is minus 1 upon 0. That is minus infinity. So sign change has taken place. Now here in this equation, if you substitute epsilon is equal to 0, this is 0, this is 0, minus 1. Minus 1 upon minus 1 is plus 1. So once again sign change have taken place. So next, if you see here, this is a special case. Here, if you substitute epsilon is equal to 0, this is also epsilon, here also epsilon. In numerator, once again, it has become 0. And this term is also 0. Second term of S1 row has to be 0. So whole row has become 0. So what happened in this particular problem is, earlier only one element in the first column has become 0. And subsequently after solving, whole row has become 0. So such type of, now you cannot take this as an auxiliary equation and solve. So why it is happening is, there are three possibilities. So symmetrically placed roots on real axis, symmetrically placed roots on imaginary axis, repeated roots on imaginary axis, or roots having same real and imaginary part but opposite sign. That is quadrate. So multiple of these combination when comes into the problem, this case happens, which is very rare. Then how to proceed further? Now what you have to do is, this row has become 0. So take it as an auxiliary equation. You take the auxiliary equation. S square, this row has become 0 means, that is s to the power 1 row has become 0 means, this becomes a auxiliary equation. So this auxiliary equation is minus 1 upon minus 1 is plus 1 with a square term. So a square plus 1 is equal to 0 is the auxiliary equation. After substituting epsilon is equal to 0. If you substitute epsilon is equal to 0, this is 0, this is 0, minus 1, this is 0, minus 1. Minus 1 upon minus 1, 1 will be there. This is also 1. This corresponds to a square term. This corresponds to s to the power 0 term, not s to the power 1 term. So here you can see a square plus 1. Divide the whole equation by this auxiliary equation. That means highest power of s is s6. So s6, take this, divide this equation by s to the power 1. Actually, you do the division. If you do the division, see, out of 6 roots, 2 roots are removed. Remaining 4 roots are here. Remaining 4 roots are here. So you can go on dividing like this. S square plus 1, you are dividing this. First you have to take S fourth. Divisive is S fourth. If you do S fourth, then S fourth plus 4, S fourth plus, that is sixth plus S fourth will be there. S sixth plus S four you subtract, S sixth term will vanish, S fourth term out of 2, 1 will go, that means 2 S fourth will remain. Next, you have to do S cube. So S cube into S square is S5, that will vanish. Then 1 S square S cube will come, so 2 will remain. Now 2 S fourth, 2 S cube will remain. Then you go for next, that is S square. If you make S square, that is 2 S square you have to do. If you do 2 S square, then this S fourth term will vanish and this 1 S square will remain, S2 S cube will remain. And this way you go on dividing. The remaining polynomial is like this. You actually divide it. We have not done it. You actually divide it. So if you divide it, the remaining polynomial is S fourth plus S cube plus 2S square plus 2S plus 1. Now check the stability of this. Check the stability of this. See here, 1, leave this, next 2, leave this, next 1. Take this 1, this is 2, 0. So this will become 0. So substitute it by epsilon. Then 1. Then you substitute 2 epsilon minus 1 upon epsilon minus 1. Now you can check the stability of this. S square plus 1 is equal to 0 has 2 roots, 1 at plus 1 and 1 at minus 1. They are on the j omega axis. They are not on the right hand side of the S plane. Positive, negative, positive, that means 2 sign changes are there. So out of 6 roots, there are 2 sign changes, means 2 are on the right hand side. Remaining 4, out of which these 2 are because of auxiliary equation, they are on the imaginary axis. And remaining 2 are on the, maybe on the left hand side or anywhere on the imaginary axis, we don't know. So overall, the system is unstable. Overall, this system is unstable because there are 2 sign changes. But you cannot directly proceed like this. You cannot directly proceed like this because this term has also become 0. Here it has become 0. Here also it has become 0. In normal problem also, sometimes it happens. If you put epsilon, then once again it will become 0. Then this is the method you have to follow. That means you have to take the auxiliary equation, divide that auxiliary equation to the main equation, and remaining equation you have to check for the stability. Is it clear? We'll share this. If you perfect this much, you can solve any type of problem. This same problem you may not get in the exam. Different polynomial will come to you, but the method remains same. So you try to perfect these 6-7 problems. If you solve on your own once without looking at them, you can solve any problem in the Routh stability criteria. Is it okay?
Yes.
Okay, we can stop here today.
Yes,
In the next, yes. Any questions?
No, sir.
Okay. So in the next class, we'll start remaining part of this same unit, but a different chapter that is called as Routh-Laqueusse technique. It is more advanced than this. So here you can stop recording. You can leave the meeting.
Thank you, sir.
Okay. So see, the portion is already put in the. I will put the portion, but as it is same as that time response analysis and stability, this Routh stability criteria. Okay.